Branches of chemistry. There are many types of chemistry. Here, we will discuss major types of chemistry and their uses. Ever watched a mystery series in which the detective recovers an unidentifiable sample from the scene of the crime and runs it through a series of tests? This is what comes in analytical chemistry. Analytical chemistry. Analytical chemistry is the study involving how we analyze the chemical components of a sample. For example, how much caffeine is there in a cup of tea? Are there drugs in an athlete's urine samples? Examples of areas using analytical chemistry include forensic science, environmental science, and drug testing. Analytical chemistry can be divided into two main branches: qualitative and quantitative analysis. Qualitative analysis employs methods and measurements to help determine the components of substances. Quantitative analysis, on the other hand, helps to identify how much of each component is present in a substance. Both types of analysis can be used to provide important information about an unidentified sample and help to identify what the sample is. Biochemistry. The fact that sweating cools the skin is a function of strong forces of attraction between water molecules. Our body maintains blood pH because of an elaborate bicarbonate buffering system. The mad cow disease in humans is caused by a misfolded protein. Does this give you a clue about what biochemistry is? The study of chemical processes in living organisms is called biochemistry. Everything in the body is made up of atoms and molecules of different chemical compounds, like carbon, oxygen, and hydrogen. This is what we study in biochemistry. Biochemistry can further be divided into interesting disciplines like enzymology, which is the study of enzymes, endocrinology, which is the study of hormones, clinical biochemistry, which is the study of diseases, molecular biochemistry, which is the study of biomolecules and their functions, organic chemistry, the study of carbon compounds such as fuels, plastics, food additives, and drugs. Organic chemistry deals with the study of carbon and the chemicals in living organisms. An example is the process of photosynthesis in a leaf because there is a change in the chemical composition of the living plant. Have you ever wondered who makes your hair conditioner or the drug you take when you have a headache? Organic chemists are the ones who do these. They devise experimental methods to isolate or synthesize new materials and study their properties. Would you like to be an organic chemist in the future? The branches of organic chemistry involve many different disciplines, including the study of ketones, aldehydes, hydrocarbons, and alcohols. Inorganic chemistry. Would you like to know how our Earth forms gold? This is what inorganic chemists do. Inorganic chemistry deals with elements and compounds other than carbon or hydrocarbons. It covers all materials that are not organic and are termed as non-living substances. Those compounds that do not contain a carbon-hydrogen bond. Compounds studied by inorganic chemists include crystal structures, minerals, metals, catalysts, and most elements on the periodic table. Industrial chemistry. Industrial chemistry is the branch of chemistry which applies chemical and physical processes towards the transformation of raw materials into products that are of benefit to humanity. Nuclear chemistry. While the common perception is that nuclear chemistry involves only the study of radioactive nuclei, it is much more interesting than that. Nuclear chemistry is the study of the chemical and physical properties of elements as influenced by changes in the structure of the atomic nucleus. Modern nuclear chemistry, or radiochemistry, is now very interdisciplinary in its applications, ranging from the study of the formation of elements in the universe to the design of radioactive drugs for diagnostic medicine. Which of these branches interest you the most? Do tell us in the comments below.